All right, so SAS 3, page 15, everybody's on that? Yes? Okay. All right, so does this picture look familiar? Yeah. Yes. That's what we did yesterday, or not yesterday, day before yesterday, that we got a little stumped on. All right, we determined that it was a geometric sequence because we multiplied by the same thing every time. Okay? Do you remember what we multiplied by every time? 4 over 3. Okay? So, jot that down somewhere on number 1. Just remember 4 over 3 because we're going to use it in just a minute. So, we got 4 over 3. All right. So, number 1 says the sequence of perimeters of the figures formed by dividing sides of an equilateral triangle and drawing new triangles can be thought of as a function. Well, we know that. All right, so on A, it says, what is the domain of a function? So think back, maybe Algebra 1, maybe 8th grade, I don't know, sometime. What is domain? Is domain X or is domain Y? It is X. Those are our input values, okay? So, on your paper where it says, what is the domain? I want you to put an X above that domain. So, like, mine's below it, so I'm going to put an X right there. Okay? What is the domain? Looking at this graph, okay, our input values are the figure number, and our output values are the perimeter. Okay? So, what is the domain? What is the actual set of numbers that goes with that domain? One, 2, 3, and 4. Okay? That's what I'm putting in to my equation. Now, the second question asks, what is its range? Well, if domain is X, then range has to be what? Y. Range has to be Y. So, on your paper, out beside range, I want you to put Y. In this case, is range my figure number or my perimeter? My perimeter. So what is the set of numbers I got for the perimeter? The first one was 3, 4, 16 over 3, and 64 over 9. Using this chart right here. So question on what a domain is and what a range is. All right, now if domain is X and we are just given a graph, are we going to look left to right for the domain or bottom to top?
Left to right.
We're going to look left to right because it is X value. Remember, X runs this way, okay? If it's a range, we're going to look from the bottom to the top. So just put that in your brain somewhere because we'll use that later on. All right. If you click check, it'll tell you the domain is a set of positive integers, okay? And the range tells you what the range is. All right, now it says, how could you use function notation to represent the sequence? Okay. Function notation is what we just did on the board, those problems. Okay? So it always gave us the first term, right? All right, so here we want to write what the first term is. So f of 1 equals what?
3.
It equals 3. Tells us right here. What does f of 2 equal? 4. F of 3? 16 over 3. And f of 4 will be 64 over 9. Okay. Now the function notation is that formula. All right. So we've got f of n, which is also can be known as what equals? Y equals. Just a fancy function notation. Okay. Now, what did we determine the sequence was? Was it arithmetic or was it geometric? It was geometric because we have a common ratio, or it also can be called a constant what? Multiplication. Okay, we multiply by the same thing. Now, what did we write down when we started? What was that common ratio? It was 4 over 3. So 4 over 3 times f of, what do you think is going to be that f of? N minus 1. Because you have to know the previous term to get the new term. Okay? If you hit check, it'll show you the same thing. Oops. All right, go ahead and hit your green arrow if you're following along. All right. It says, on the screen, as with arithmetic sequences, geometric sequences can be used to model other situations besides geometric problems. Consider this situation. Once the remodeling project for the school auditorium is finished, the drama club wants to stage a production for the community so they can see the results of the renovation. They plan to give one performance every night except Sunday and Monday for 2 weeks. Okay, so what is 2 weeks? How many days? 14 days. All right, I'm doing that for 2 weeks, except I'm not going to include Sunday and Monday. So I'm going from 7 days a week to how many? 5 days a week. Because Sunday and Monday, we're knocking them out. So we got Tuesday, Wednesday, Thursday, Friday, Saturday for 2 weeks. So now how many days do I got? 10 days. Okay. All right. It says, based on advanced marketing, they believe the revenue from the first night's production will be approximately $3,500. So what is the first term? What are we going to make that first night? $3,500. Then it says their past experience with similar productions indicates that for each night after the first, the revenue will be 70% of the previous night's revenue. That's that recursive definition. How do we know it's that recursive? What word does it say? Previous. Okay. So on your paper, I'm reading the same thing, but it's a little bit different. So I want you to circle 3,500, and I want you to underline 70% of the previous night's revenue. And then it says, use this information to estimate the projected revenue for the first 5 nights of the production. Okay. So, geometric sequence. Y equals first term times common ratio n minus 1 in the exponent, because what did we determine on Wednesday? What type of function went with geometric? Linear, exponential, or quadratic? Flip back to page 1. Exponential had a constant what? It has a constant multiplication. And what do you know about geometric sequences? They multiply by the same thing every time. Okay? So they correlate. So that's why that n minus 1 is in the exponent, because it shows it is an exponential function. Okay? So let's make a function rule. Y equals. What does it say the first term is? How much money am I making that first night? What's it tell me? $3,500. Times my common ratio. 70%. Okay, now tell me this. Can you put a percent in a formula? You have to change it to a what?
Decimal.
You have to change it to a decimal. All right, so we've got 70%. How do I change percent to a decimal?
Move the decimal to
I move it 2 places to the left. So 70% is the same thing as 0.7. Good. So we got 3,500 times 0.7 n minus 1. All right. Now, we are going to use this, and we are going to use our calculators to determine night 2, night 3, night 4, and night 5. Got it? So, first, all right, we've got 3,500 times 0.7. To get it in the exponent, you use this little arrow right here. Now we're looking for night 2. So what am I going to plug in for that n? 2 minus 1. Enter. You should have gotten 2450. Did you get 2450? All right, I want you to do the same thing for night 3, night 4, and night 5. But what is the only difference that you are going to do? You're going to plug in a different number for n. So for night 3, what number are you plugging in? 3. For night 4, where do you plug it in? 4. And for night 5, where do you plug it in? 5. Do that right now. And if I were you, I would draw that that chart on number 2, like you have on your on the screen. Yes, absolutely. All right, and what did you get for night 3? Anne, not Dylan. 1715. Did everybody get 1715? Yes? Okay. Hannah, what did you get for night 4? Good. $1,200.50. And Caesar, what did you get for night 5? $840.35. Did everybody get those correct? Yes. Good. All right. All right. Let's see. Oh. Okay, so on that next screen, it's just showing you what it's doing. Okay? What you just did in your calculator. Sometimes it has a lot of screens that we do not need. Like all these. Alright, we're doing number 3 though. Okay, so it says write the recursive definition for the revenue, which we've already written. Okay. Then find the general formula for T in terms of N, and use the general formula to predict the revenue for the 10th night. Okay, so what was the formula that we used? Y equals 3,500 times 0.7. What was in the power? N minus 1. All right. Now, I want to find the 10th night. Okay. So, here, do you see an F of something? You don't see the F. Okay. So, when you don't see that F of, that means you don't have to have the previous terms. Okay. So, here, I'm just looking for the 10th term, 10th night. So, T10 tells me I plug in 10 for N. So, we've got 3,500 times 0.7, and the power is going to say 10 minus 1. Well, we still simplified, though. What is 10 minus 1? 9. All right, so now we've got T10 equals 3,500 times 0.7 to the 9th power. Type that in your calculator. Noelle, what did you get? Yeah. 141 All right, 141 point a bunch of numbers. If we are dealing with money, how many decimal places do we need? We need 2. So it'll be 24, because that 7 makes it round up. Did everybody get 141.24? Good. All right, number 4, you can cross out. We will not do number 4. All right, go ahead and go to number 5. Okay. Number 5 says, calculate the total revenue the drama club can expect to earn from 10 nights of the performance. Okay. So, I'm going to hit this play. And it's going to show me a function rule. This is showing us the I don't like this. Okay, let's go to page 2 and see what it does. Okay, not a fan of how they teach this. All right, so I'm going to do a different one. All right, so yesterday we talked about that sigma, right? What did that sigma mean? We're finding the what? The sum, okay? Sum and total mean the same thing, right? Okay, so let's use a sigma to find this. Here's my sigma. How many nights am I looking for? 10. So where's 10 going to go? On the top. On the bottom, it's going to say n equals 1 unless you're told something else. Okay? Now, what was the function rule we used? 3,500 times 0.7 n minus 1. All right, so what this means, this is a sigma if I expanded it. Okay, I'm expanding it all the way out. I've got a T1, T2, T3, T4, T5, T6, T7, T8, T9, and a T10 because I have that many terms. All right. Now, I want to know how to do this very quickly without having to do that 10 times. Okay? So, what we write next is something you want to box, underline, circle, something, because you got to know it. It's a formula. All right? So I'm going to erase this. I want you to write SN equals T1 times 1 minus R to the n power divided by 1 minus R, close the parentheses. All right, what do you think that S stands for? Sum, okay. T1, what term is that? First term. What do you think that R stands for? The ratio, the rate. And that N is the number of terms we're looking for. Okay, so let's write SN equals sum. T1 equals first term.
I need Lee Anthony to check out, and he needs to go by and pick up a slip.
Okay.
Thanks.
R equals the common ratio. And N equals number of terms. All right, so we know all this information. We're looking for S of 10 equals, what is the first term? 3,500. Parentheses, 1 minus my R. What's my rate? 0.7. How many terms am I looking for? 10 divided by 1 minus 0.7 again. Ballet. So all I did was plug that in. I hadn't even done any math yet. Okay? So, get your calculators. Everybody got this written down? Okay. All right. So, first, 3,500. Okay? Parentheses. Now, I want to put a fraction bar in because I got something on top and the bottom. So we hit alpha, y equals, enter to get our fraction bar. What's on the top of the fraction? What's it say? What's the top of your fraction say? Did you write it down? What is it? 1 minus 0.7 to the 10th power. And what's on the bottom?
1 minus 0.7.
1 minus 0.7. Thank you very much. Now, you have to close that parentheses all the way over. You should get $11,337.11. Did you get that? All right, that's how you have to type it in. If you do not type it in that way, guess what? It's wrong. Okay? So you have to type it in exactly how you wrote it. All right? So it was 11,337.11. Okay? Now, numbers 7 and 8 is a reinforce. So, we're not going to have time in class to do it, but I do want you to do it sometime before you come back on Wednesday. Okay, so just add this to your virtual work on Tuesday. So, you don't have to do C. You only do 7A and B. 7 is like what we just did using that long S of n formula. Okay? And B is writing it in sigma notation. Got it?